Okay, so today we're going to talk about coordinate geometry, and coordinate geometry has got a lot of circle kind of stuff in it, and quite honestly, that's relatively new. It used to be pretty different. The coordinate geometry questions did always involve a lot of finding equations of lines and doing with perpendicular and parallel lines, but they've only introduced the circles a couple of years ago, and so now I see most of the time, a lot of time, that the coordinate geometry questions are linked in with the circle information. So basically, in this first one, it says that we've got this circle equation, and they want us to find the x coordinates of A and B. All right, so the x coordinates of A and B where there intersects the x-axis. And see, this is an important thing to keep in mind, because basically what they're talking about are x-intercepts. And an x-intercept is where y equals 0. And see, all I've got to do now is take this and rewrite this equation, but make all the y's equal to 0. And see, when I get this out of the way, I get x squared minus 4x minus 77 is equal to 0. And then it's a quadratic, and I've got to solve this quadratic by factoring. I look for two numbers to multiply to get to 77 and subtract to get 4. Minus 11 and plus 7 will do the trick. And that gives me an x value of 11 and an x value of negative 7. Now it only asks for the x coordinates, all right? But keep in mind those are x-intercepts, so those points are going to be 11, 0, we'll say that's A, and then negative 7, 0. And we'll say that's B. And when they don't specify, then just pick them, don't worry about them. Okay? So now it says, that's part A. Okay? Now part B, it says find the point of intersection of the tangents A and B. All right, so let's give you a little picture of this. So I've got a circle, and here's my center point. And I would be awesome if I knew what my center point is, just so I get a sense of where this was. So let's go ahead and find the center point. If I'm going to do this, what I'm going to do is I'm going to complete the square. I'm going to get the x stuff together. X squared minus 4x, and then I'm going to leave a gap. And then I'm going to put the y stuff together. Y squared plus 6y, and then get rid of the constant by adding it to both sides. And so now it looks like this. And see, now I'm going to take this middle term and I'm going to divide it by 2 and square it, which is going to give me a plus 4. But the reason I'm doing that is because when I factor this, it's going to be x minus 2 squared. And so I'm rewriting this as a circle in standard form. And so now I get the other one. And I'm going to do y and take this divided by 2. So that's going to be 3. 3 squared is going to be 9. And again, when I factor this, it's going to be y plus 3 squared. Whoops, squared. Now what you got to keep in mind is I've added a 4 that wasn't on this side before and a 9 that wasn't on this side before. So I've got to add that to the other side to keep things equal. And so that's going to give me 90. Now the point of all this is that now that I have this, I can tell you what the center is. This is going to be a center of 2, negative 3. All right, so we can label that 2, negative 3. And see, now what I want you to get is A and B. So this is clearly going to be somewhere around here. Point B, and then if I go across here nice and level, because you see how they both are x-intercepts. This is the x-axis right here. And so this is going to be somewhere over here, and it's going to be 11, 0, and that's going to be point B. Oops, not point B, point A. All right, now tangent lines. So tangent lines are going to go and touch that circle at one point. And so what I'm going to do is I'm going to see if I can make a tangent line. And it's going to go extend this way. And then on the other side, and then clearly these 2 points are going to intersect, and they want to find that point. And so what we want to do here is I want to find the equation of both of those lines. And in order to do that, in order to find a linear equation, I need a slope. And so the point, what they're trying to get at here, is that when I've got a point on the circle, and a tangent line touching the circle at one point, going to the center, these two lines are always going to be perpendicular. So that means their slopes are going to, if I can figure out one slope, I can figure out the other. So let's go ahead and do this. If I want to find the slope of, say, AC, we're going to call this C for the center. So the slope of AC, and this is a formula that you have to know when it's not on the formula sheet. Is going to be -3 minus 11. I'm going to subtract the y's. -3 minus 11. So that's y2 minus y1. And then 2 minus 0. Nope. I've screwed this up. Let's try this again. The center is 2, -3, and A is 11, 0. So y2 minus y1 is going to be 0 minus -3, and then 11 minus 2. And so what I'm going to get is I'm going to get 3 over 9, which is 1/3. All right, so that makes this slope 1/3. Which means this slope has got to be, what did I do wrong? Because, oh, -3, opposite reciprocal, it's perpendicular, right? So if it's going to be perpendicular, that means it's going to be the opposite and then the reciprocal. It'll be -3. So this slope is going to be -3. Now, you can figure it out, but what's going to happen is, you know, this is symmetry here. Notice how these both are lined up, all right? If I go and do the other slope, what's going to happen is that I'm going to end up doing, the center is going to be 2, -3, and then that point is going to be -7, 0. If I find this slope, it's going to be -3 minus 0 over 2 minus or plus 7. And I'm going to get -3 over 9. And that makes this -1/3. And that makes this slope +3. All right, so anyway, you can see this is worth a lot of points because there's a lot of stuff that has to happen. In order to get these equations of lines, I need the slope, I've got a point, and so now what I got to do is I got to go ahead and create these two equations. And I just start with y equals mx plus b. And if I've got this point here, this is going to be 0. My slope is going to be 3. My x is going to be negative 7 plus b. And so that's going to give me a b of 21. And so my equation is going to be y equals 3x plus 21. That's this. And then I'm going to do the same thing on the other side. And I'm going to do 0 equals, and then 11 times negative 3 plus b. And that's going to give me an equation of a line of 33, or my y-intercept is going to be 33. So that's going to be negative 3x plus 33. And see, that's this guy over here. Whoa, what happened there? And see, now all I've got to do to find out a point where two lines intersect, I'm going to solve them simultaneously. And so basically I'm going to take this 3x plus 21 and make it equal to this negative 3x plus 33. Add 3x on both sides. I'm going to get 6x and then subtract. And I'm going to get 12. And so then x is going to equal 2. All right, so this point has got a 2 wherever these guys intersect. Right? It's got a 2, which kind of makes sense, and we could have probably anticipated this and guessed this, but do you see the symmetry here, how this would have been a 2? All right, but anyway, and so then I plug it back into one of the points. This is going to be, we'll say y equals negative 3 times 2 plus 33, and so that's going to give me negative 6, and then negative 6 plus 33 is going to be 27, and so the y is going to be 27. And see, this is the point where they intersect. Okay, so it's a decent amount of work. It's worth a lot of points, and I just want you to know that basically all we've done is we've taken a circle equation and rewrote it in standard form so we could get this center, and then what we've done is that we found the slopes of the two tangent lines by finding the slopes of these lines, finding the opposite reciprocal, which is going to be the perpendicular slope, and then created the equation of a line. With an equation of a line, all you need is a slope and a point, and then we find out where they intersect. And like I said, quite honestly, this captures a lot of the skills that are going to be necessary for doing well on the coordinate geometry question. All right, so let's take a look and see what the rubric says. All right, so you can see here y equals 0, so they are telling you when y equals 0, so that means to end up with this quadratic, they want us to factor it. All right, so there we go. That's simple enough. And then they give you the answer. So using this method, which basically means put the y is equal to 0, is going to give you a point. And then getting the right answers is going to give you another point. That's 2 points. And see, then in part B, there's a series of different things. And like I said, the first thing is you got to be able to find the center. That's where the point. Now, then you've got to find the slope of the two sides, and that's negative 1/3 or 1/3. You could have found either one. And that's a method point, okay? And then find the slope tangent, which is going to be the opposite reciprocal. So we're finding one or the other, right? Find the perpendicular gradient. That's a method point. and then find either equation. That's going to get you a point. And then find out where they intersect. That's going to give you a method point. And then finding the point, that gives you the last point. Now, I'm telling you, well, that's, I mean, like I said, that's a lot of different stuff. But that's basically the kind of things they're going to be looking for. All right, so let's take a look at this next one. What I want you to do is I want you to pause this and read this question and see if you can figure something out, and then start back up again, and then we'll compare notes. Okay, hopefully you did that. We've got points A and B are the coordinates A, 8, 3, and PQ, respectively. All right, so that means this is A and this is B. The equation of the perpendicular bisector, AB, is y equals negative 2x plus 4. And see, it's kind of important that you understand what a perpendicular bisector is, so let's make sure we're clear on this. If I've got point A and point B, there's going to be a line that is going to intersect at its middle point, and it's going to be perpendicular. So what I'm looking for is a line that cuts A and B in half, but also creates a right angle at this. Now what they're telling me is this is y equals negative 2x plus 4. Again, you'll notice how we're dealing with this perpendicular thing again. So hopefully the first thing you thought to do was to figure out the slope of these 2 points is going to be the opposite reciprocal. I know the opposite reciprocal is going to be the slope of AB has to be positive 1/2. And so I've got a point, all right? Now, I'm sorry, I've got a slope. And I also have a point that they gave me, point A is 8, 3. And so what I'm going to do now is I'm going to go and find the equation of a line. If you didn't do that already, pause it and find the equation of the line AB. Okay, hopefully you did that. Typically, you can use point slope form, but I just use this. Y equals mx plus b. And then this is going to be y, and then my slope is going to be 1/2, and then my x. And then I find the y-intercept. And so this is going to be 4, and then 3 equals 4 plus b, which means b has to be negative 1, which gives me the equation of AB as being y equals 1/2 x minus 1. All right, now that's AB. Now, how can I use that to help out? Well, what I know is, I know that these 2 lines, AB and the perpendicular bisector, must intersect. So if I find out this point right here, well, that's going to be very helpful in finding out this point B. Because if you think about it, this is an end point, and this is a midpoint, and this is another end point. And see, being able to use the distance formula and the endpoint formula are very important skills. They also come up along with slope and writing equations of lines. In this case, I'm going to be able to figure out the end, and I'm going to be able to figure out the middle, and then I can find the other end. So anyway, if I make these equal to each other, it's going to equal 1/2 x minus 1 is equal to negative 2x plus 4. Now, again, it's not that big of a deal, but you may find it easier to get rid of the fractions. If I want to get rid of this fraction, I can just multiply everything by 2. But if I do that, I just got to make sure I multiply everything by 2. 2 times this is going to be x, and then 2 times this is going to be negative 2. 2 times this is going to be negative 4x, and 2 times this is going to be 8. And so, like I said, if you'd like to get rid of fractions, then go ahead and do it. So anyway, I'm going to go ahead and add 4x to both sides. And I'm going to get 5x, and I'm going to add 2 to both sides. It's 10, and I'm going to find out that x is going to equal 2 at this point right here. Now, what I need to do is figure out the y value, and I can take either one of these points. Let's go ahead and use this one. So negative 2 times 2 plus 4, and that's going to give me a value of 0. So that point is 2, 0. And this end is 8, 3. And this is PQ. All right, now, all we got to do is figure out this end point, and we're going to do it separately. Because remember, the midpoint formula is I take the x's and add them together and divide by 2, and the y's and add them together and divide them by 2. That gives me the midpoint x and the midpoint y. Well, that's what we're going to do here. If you haven't done that, go ahead and see if you can figure out what the end point is. Pause this and then start back up again. All right, so hopefully you did that. Basically, if you just think about it, I know this one x, and so it's going to be 8 plus x divided by 2 is going to equal the midpoint x, which is going to equal 0, or I'm sorry, 2. And then the y, which of the end, is a 3, and the other one I don't know. Technically, I could call it q. Probably should call it q. You know, I should probably call the other one P. Keep things straight for you. All right, but anyway, that's going to get divided by 2, and it's going to equal the midpoint y, which is equal to 0. And so when I multiply both sides by 2, I'm going to get 4 is equal to 8 plus p, and then p is going to equal negative 4. And then when I multiply both sides, I'm going to get 3 plus q is equal to 0. And q is going to equal negative 3. And that gives me the point B is going to be negative 4, negative 3. Or, as they specifically asked, find the values of P and Q. And I want you to notice that's a good habit. I always go back to the question and make sure I actually answered what they asked for before I move on. All right, so let's take a look. You'll notice how they found that you can get a point for recognizing the slope of AB was the opposite reciprocal. 1/2. The lines meet, so the one line, the perpendicular bisector, and the other line, they used point slope form, doesn't make a difference. But basically all they want to see is the method of you equating the bisector with the other line. And if you were to use the incorrect slope that you had figured out in the other part, they would still give you this method point. And then the same thing here is use the midpoint formula like we did. And again, if it's screwed up from before, you can still get a method point here for doing the right thing. But then at the very end, you got to get the right answer to get the last 0.4. So one of the nice things about this is you can screw this up a little bit and still get half the points. So it's really important that even if you think you've screwed it up, to keep on going and try to get some points whatever you can. All right, so let's take a look at another one. Here, it says that I've got point A, and it's got coordinates, and I've got a line with a slope of negative 2/3. And so then it passes through A. So that passes through this point right here. The line passes through that point there, and a circle has a center of 511, and then the radius of square root of 52. So the first thing they want to do is they want to show that this is that L is tangent to the circle at A. All right, so again, let's see if we can't. You don't have to do this for the test, but I'm trying to just do this to kind of make sure we get a clear picture. All right, so there is my circle, and if this is the center point, which I know is 511, and we'll call it C. And then we've got this point 1,5, and again, if you think about it, it's going to be below here because this y is 11, and it's going to be on this side, so 1,5 is going to be somewhere over here. Doesn't have to be exact. So there's our point A, 1,5, and this line passes through point A, and we want to show that this line is tangent. So what we've got is about a line that goes through, it touches a circle at one point, and we've got to show that this is tangent, okay? And again, this is, again, really relying on this premise again of if I've got a center point and a tangent point, they have to be perpendicular. So what I want you to do is pause this and see if you can't show that line L, this line here, is actually tangent to circle A. Pause it and start back up again when you're ready. All right, so hopefully you did that. If we're going to try to figure this out, what we're going to do is that the first thing I want to do is I want to prove that the slope between AC and the slope between, and this slope here is going to be perpendicular. And so let's try that. So AC, the slope of AC is going to be, if I've got the point A and the point C, if I find those two slopes, it's going to be 11 minus 5 over 5 minus 1. This is going to be 6 over 4, which is going to be 3 over 2. All right, now what that means is if this slope, AC, is this, that this slope here has to be the opposite, which is negative, and then the reciprocal, which is going to be 2/3. All right, so now that's the slope that it should be. And it clearly says that the slope of the line is negative 2/3. So I'm feeling pretty good about the fact that this is, it's at least creating a right angle at this point. All right, so now the next thing is I've got to make sure that this 1,5 is actually on the circle and not somewhere else. And so if I take the circle equation, which they've given me enough information here, if I do x minus 5 squared plus y minus 11 squared, it's going to equal this squared, which is 52. And if this point is actually on the circle, meaning touching the circle, well then that means that when I plug in the values of 1 and 5, that it's actually going to equal 52. Because every point on there should make this equation true. And so here I've got a 16, 1 minus 5 is negative 4, 4 squared is 16, and then this is going to be negative 6, so that's going to be 36, and when I add those together, I am going to get a 52. And so that shows that A is on the circle. That's the first part, okay? So that means it's actually on the circle, and this point, 1, 5, is on the line that goes through A, and the line L is perpendicular to AC. It must be tangent. And then in part B, it says find the equation of the other circle. No, find the equation of the other circle of radius 52, which L is also tangent to A. All right. All right, so basically here's what we're talking about. I'm not sure if I can pull this off. I'm going to try this. We're talking about another circle that's tangent to that same line. And so if you think about it, what's going to happen here is that it's going to have a center point. Whoops, let's make this a drawing thing. It's going to have a center point, all right? And this point A is going to be in the middle. And since they have to have the same exact radius, they're going to be the same distance from each other. So at the end of the day, what's happening is we've got another situation where they've given me an end point and a midpoint, and I got to find the other end point. That's my circle. So if you weren't able to do that, why don't you go ahead and pause this and try to find the point here, the other end, and then start back up again when you're ready. All right, so hopefully you were able to do that. And so basically all we're going to do here is the same kind of thing. I've got 5, which is my x value, plus another x value that I don't know. And I'm going to divide it by 2, and it's going to equal the x value 1. And then I've got this 11, and I'm going to add it to the other y value of the other endpoint, divide it by 2, and it's going to equal 5. And all I'm going to do now is get x and y by itself. When I multiply both sides by 2, this is going to be 5 plus x is equal to 2. X is going to equal negative 3. And then this is going to be 11 plus y is equal to 10. Y is going to equal negative 1. The center of this circle is going to be negative 3, negative 1. And if I want to write a circle equation, all I got to do then is do x plus 3 squared plus y plus 1 squared, and it's going to equal this squared, so it's going to be 52. All right, does that make sense? Hopefully it does. Let's see what the rubric looks like. All right, so again, you can see here how we find, they plug in this point and find out that it's true. I guess you could also use the slope. All right, but they method point, you can give you that. And then some kind of clear explanation. And see, with these show questions, it just can't be math. I mean, in this case, I want you to understand what happened here. I proved that A is actually on the circle, and then I proved that AC is perpendicular. And so if that line is actually going through A, it must be a tangent line, because tangent lines are perpendicular to points on the circle. And so, that's what I need to do. I need to say something like that. And then in B, they give you, find the center of -3, 1, and you get the point for each coordinate being correct. So again, this process here, this is worth a point, and this is worth a point. And then writing the equation is another point. And if you screw up the center and then still get this correct, you can still get this point. If this center is incorrect, but you do this part correct, you can still get that. Okay, let's take a look at this one. It says the diagram shows a circle with a center A passing through point B, all right? And then the second circle has center B and it passes through point A. The tangent of B to the first circle intersects the second circle at C and D. All right, so now most of this information is on this picture, which is good. However, I want to add to the picture that this is -1, 4. And then the B is 3, 2. It's going to help me. I just feel like it's going to. Okay? And now the first thing they want to do is they want to find the equation of this line, CDB. So basically they're talking about this. Do you see where it says CDB? They want me to find the equation of this line. Now keep in mind, whenever in order to find any equation of a line, you need to have a slope and a point. Now, I have a point. Point B is clearly 3, 2, and it's on this line. And so all I need to find is its slope. And what they want me to do is know that this is tangent, and they told me it was. So that means if I go from here to here, it has to create a right angle. Okay? And so if I can find the slope AB, it's going to be perpendicular to the slope of CD. And then I'll have a slope and a point, and I can write the equation. So let's try that. Pause it and see if you can't figure out the equation of CBD. And then start back up again when you're ready. Okay, so hopefully you did that. Let's take a look. If I'm going to find the slope of AB, and it's a good idea to label everything, because you never know when you're going to have to go do it again. So if I've got these points, A, -1, 4, and then B is 3, 2. If I find the slope, which is going to be y2 minus y1, it doesn't matter where I start, just as long as I'm consistent. So I'm going to do 4 minus 2 over negative 1 minus 3. And that's going to give me 2 over negative 4, which is going to be negative 1/2. All right, so there's my slope of AB. And if you look at it, it does appear to be negative, so I'm feeling good about that. And that means that the slope of CD is going to have to be the opposite reciprocal, which is going to be 2. And again, if I've got a point and a slope, which I do, I can find the equation of a line, and all I'm going to do is I'm going to plug it into y equals mx plus b. This is the y, this is the slope, this is the x, and then I got to find the y-intercept. And so if I have 6 and I subtract on both sides, I'm going to get the y-intercept is going to equal negative 4. And so my equation is going to be y equals 2x minus 4. And see, that's the answer to the question A. All right? Now, in B, it says find the equation of the circle with center B. All right, well, that shouldn't be too hard. If I'm going to find a circle equation, then I need a center, and it would be awesome if I had a point that's actually on the circle. And so I do have both those things. So if I'm going to find the equation of a circle, I need a center. The center is point B, which is 3, 2. And then I wish I had a radius, so then I could make it equal to the radius squared, but I don't. But the other thing that's okay then is if I have a point that's on the circle, which in this case, they told me this is, A is going to be negative 1, 4. So what I'm going to do is I'm going to start by using this, x minus 3 squared plus y minus 2 squared, and that's going to equal the radius squared, which I don't know what that is. So now what I'm going to do is fill in this x and this y into the circle equation, and it's going to equal that radius squared. Go ahead and pause that and try that, and then start back up again when you're ready. Okay, so hopefully you did that, and if you do fill it in, this is going to be negative 1 minus 3 squared, and this is going to be 4 minus 2 squared. This is going to be negative 4 squared, which is going to be 16, and this is going to be 2 squared, which is going to be 4. And that gives me this 20, and that is going to be the equation of the circle B. All right? Now, find the circle equation B. All right, now, find, by calculation, the x-coordinates of C and D. Okay, so C and D, that's this point here and this point here. All right, there's a couple different ways to look at this, and this line touches the circle B at those 2 points. So basically, if I solve these simultaneously, then I should find the x values or the y values of these 2 points. So what I'm going to do is I'm going to take what y is equal to and then put it in place of y in this circle equation. So it's going to be x minus 3 squared, and then instead of y, it's going to say 2x minus 4. It's still going to say minus 2 squared, and then it's equal to 20. All right, now what I'm going to do here is I'm going to figure out what x is. So why don't you go ahead and try to do that, pause this, and then start back up again when you're ready. Okay, awesome. Hopefully you did that. This is just a binomial. We can just square it. So this is going to be x squared minus 6x plus 9. Hopefully you're good at that by now. Here we can clean this up a little bit before I square it. So this is going to be 2x minus 6. Probably could have done that before. And still equal 20. So now I'm going to square this. So this binomial gets squared, so that's going to be 4x squared, and then it's going to be minus 24x, and then plus 36. And see, now all I got to do is put all this stuff together. Let's see, 4x squared is 1x squared is 5x squared, negative 6x, and that's going to be negative 30x, and then 9 and 36. Let's see, 9 and 36 is 45, but 45 minus 20 is going to be 25. All right, so there's my quadratic. I noticed right away that everything does divide by 5, so I'm going to go ahead and do that. X squared minus 6x plus 5 is equal to 0. And that makes me happy because that's pretty factorable. This is going to be x and x. I need two numbers to multiply to get to 5 and add to get to 6. That's going to be 5 and 1, and they both have to be negative. And I solve this, and I find out that x is going to be 5, and x is going to be 1. And so that gives me my two x coordinates. And then what I'm going to do is plug these into my linear equation. And, oh wait, I'm going to take a look again. Notice here it says, find by calculation the x coordinates of C and D. Those are the x coordinates of C and D. I don't have to go any further, even though a lot of times they ask me for the coordinates. They didn't ask me in this case, and so there's no sense in doing that extra work. So there you go, that's that. So let's take a look here and see what we got in the rubric. Oops, put that twice. Yeah, okay, so you got 1 point for finding the correct slope. All right, that's AB. Then the equation of the tangent line using the point and that slope. And if you would have gotten the ring correct slope, the opposite reciprocal, then you still could have gotten credit for this. But anyway, find the equation of the tangent line using the opposite reciprocal slope. That's part A. And then B, find the equation of the circle. So finding out that the radius squared is going to be square root of 20, or I guess the radius is square root of 20. Here it looks like they're using the quadratic formula, or no, a distance formula. And then get the equation of the circle. All right, that gives you those 3 points. And then here, if we substitute in and then solve, and again, you can get this method point, but you won't get these other two if you didn't have the right stuff. Anyway, that's that. All right, one more, and we'll call it a day. Take a look at number 5, read this, and then see if you can't figure it out. At least figure out part A. Pause it, do part A, and then start back up again. Okay, so hopefully you had some luck with that. If I'm going to do A, find the equation of the circle, I have a center and I have a point. So you can see, and again, the key is it's a point that lies on the circle. So that's all I really need. If I have a center, I'm going to do x minus 5 squared plus y minus 1 squared, and it's going to equal this. Am I going to plug in my points? negative 1 minus 5 squared plus negative 2 minus 1 squared. Notice all the negatives, they love to do that. So this is going to be negative 6, and then squared is 36. This is going to be negative 3, and then squared is going to be 9. So this is going to be 45, and this is going to be 45. And this is going to be the circle equation for part A. Boom. Now, part B, it says that point C is such that AC is the diameter of the circle, and point D has the coordinates 5, 6. All right, so let's see if we can't figure some of this out. I'm not sure how much room this is going to take, so let's see. All right, so it says the center is going to be 5, 1. So I'm going to do 1, 2, 3, 4, 5, 1. So there's the center of our circle. And then A is negative 1, negative 2. So that's going to be approximately here. So this is A. This is B. All right. And it says that point C is such that it's the diameter of the circle. Well, now, if that's the case, it's got to go across here. It's going to go, there's my diameter, and it's going to go roughly the same distance. And so now, this is my point C that they're referring to. And they say that point D is the point 516. Now 516 is going to be directly, you know, this is 1, 2, 3, 4, 5. So I'm going to go up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's going to be right up here somewhere. That's point D. And again, I'm just trying to get a sense of what's going on. So it says that show that DC is a tangent to the circle. All right, so you notice that we did that before. Okay, so basically, I've got to figure out two things. Here's my circle. I wonder if I can do this. Nope. I don't know how to do it. All right, so here's my circle. I'm going to try to do it with my hand. Okay, so there's my circle. Okay? And they want me to prove that this is tangent to it. In order for that to be true, this has to be perpendicular. And so I know that point B is 5, 1. I don't know what point C is, but I do know what point A is. It's negative 1, negative 2. So I guess the first thing is to figure out what point C is. So use these pieces of information, A and B, and figure out what point C is. And then figure out what the slope of AC is, and figure out the slope of CD, or what it should be. All right, so let's take a look. If I'm going to find this slope, point of CD, find point C, I'm going to have negative 1 plus x divided by 2, that's going to equal 5. And then my other one is going to be negative 2 plus y divided by 2 is going to equal 1. I'm taking the end and making it equal to the middle. And so then I've got negative 1 plus x is equal to 10, x is equal to 11, and then I'm going to get negative 2 plus y is equal to 2, and y is going to equal 4. So that means this point over here is going to be 11, 4, which I didn't do too terribly bad, maybe a little bit short. All right, so there's 11, 4, right? All right, now the slope of BC is going to have the points 5, 1 and 11, 4. So it's going to be 4 minus 1 over 11 minus 5. And that's equal to 3 over 6, or 1/2. And so if AC is equal to 1/2, that means that CD should be equal to negative 2. And so when I do the slope CD, or if I got room here, CD is going to be 16 minus 4, y2 minus y1, and then 5 minus 11. Nope, I don't have enough room. So 16 minus 4 is going to be 12, and 5 minus 11 is going to be negative 6, and that's going to be negative 2. They are opposite reciprocals. They are perpendicular slopes. So there's that. And we can prove that 11, 4 is on the circle, like we did before, taking this circle equation and plugging the point in. 11 minus 5 squared plus 4 minus 1 squared equals 45. This is going to be 36. This is going to be a 9. It does equal 45. So they have perpendicular slopes, and C is on the circle. So if C is on the circle and the slope of BC and CD are perpendicular, they must be tangent. And then it says show the other tangent line D from D. All right, it's going to come over here. All right, so let's make sure we clear this. CD is negative 2. And again, notice how this point 5 and 5 are directly above each other. What's going to happen is like we did this before. This tangent line is going to go to D. But what's going to happen is that they are going to be perpendicular to each other, or not perpendicular. I mean, these should be parallel, and my picture doesn't really show that. Okay? All right? So 5 and 5. 5 and 5. So if this is going to be over here, this is going to be perfectly symmetrical, right? And so this is going to be some number 4. And so one way that we can do this is to figure out what is on the circle that has a y value of 4. And so if I do that, I've got x minus 5 squared plus 4 minus 1 squared is equal to 45. And then this is going to be x squared minus 10x minus, plus 25. And this is going to be 3, so plus 9 is equal to 45. When I subtract this, so let's see, this is 34, and then I minus this, So x squared minus 10x is going to be minus 11 is equal to 0. And then when I factor it, two numbers to multiply to 11 and subtract to get 10. It's going to be negative 11 and plus 1, which you can see how one of my answers is going to be 11. That's because that's this point right here. And the other one's going to be negative 1. So this is going to be negative 1, and that's going to be E. E is negative 1, 4. Now the other way to do this is to figure out the equation of the line ED and then find out where those two intersect. You'll also notice that if this is a negative 2 slope, this is a positive 2 slope. I've got a point and a slope. I can easily make those two equations. I can find out where they intersect. And they're going to intersect. Oh no, I guess I can't do that. They're going to intersect here. I can, what else can I do? Oh, I could take this line and then make it intersect with the circle, which is not going to be as easy to do as if it would be to do in that point 4. All right, so let's take a look here then. In the rubric, you can get a point for finding 45, and then you get a method point for plugging it in, and then you get the answer for getting the right point, all right, or the right equation. And then C here, they're looking for this point C. That's a midpoint thing. There's not a method point for that. You just got to be able to do it. And then the slope is a half, so that means the other slope is negative 2. And then you get, again, like I said, it's got to be some kind of reasoning. It's perpendicular, it's tangent. I include the fact that they're clearly on the circle. That should take care of that. All right, so hopefully this is helpful. I got to run. I'll see you next time.